In this week's evaluation tutorial video, we're going to show you how to apply the rubric to the two different example programs that we suggested for the final project. So that's the Simple Text Editor and the Flower Animation program. So let's get started. The first two criteria we're going to look at is the program safe and is the program commit ready? So this is the Flower Animation program, and the first thing I've done is I've pasted this code into a Dr. Racket window and pressed Command I so that all of the indentation that the Pure tool removed comes back. So now we can look through this to make sure that it fulfills the requirements for safe. So we have two requires up here, image and universe. Those are ones that we want. We can press Command F or Control F to check if there's any other requires hiding that we don't want, and there's not, so that's good. And unfortunately with the Pure tool we can't check whether or not it was in beginning student language, so this gets an acceptable for is the program safe. Now we can look through the file to check that it is commit ready. So we're looking for any comments or notes that are left behind that shouldn't be there, or any code that is commented out that shouldn't be. So if we scroll through, we've got types, comments, interps, signatures, and purposes that are commented out, which we want. And there doesn't seem to be anything commented out that shouldn't be, so that's good. We can give this a good for commit ready. So the next criteria we want to look at is, are all HTD elements complete and do they have high internal quality? So this is structured a little differently than the past design quiz. Instead of grading the completeness and internal quality separately, we're going to look at the three different recipes and grade completeness and internal quality together for each one. So for HTDW specifically, we want to look to see that the file includes constants, data definitions, and functions, that the constant section is complete. We want to check that the main function operates on the correct type and that that type is compound. And we want to make sure that all of the necessary Big Bang options are present and each one has a handler present in the file. So first let's look at the constant section. We have width and height defined, that's good. Then here's the MTS. We can see here that they've used the correct width and height for their MTS, but they've hard-coded those in rather than using the constants. So really we should use width and height here, so we have what's called a single point of control. So this would be better. Then we have this flower defined, so that looks good. So other than that small error here, the constant section looks good. We can see that the data definition is present and that it's a compound type. So we'll evaluate the actual completeness of that data definition in the next criteria. Next we'll look at the main function. It's going from flower to flower, which is good. It gives us a note about what to start the animation with. We see here that we have three Big Bang options, on tick, to draw, and on mouse, and that each one has a handler. We have these notes about the signature of each handler. Those are all correct. And we'll check to make sure each one of those handlers is present. So we see here we have top, there is render, and down here we have handle mouse. So we had one small problem in the constants. Other than that, everything is good. So we give this a good for completeness and internal quality of HTDW. So the next criteria we want to look at is the HTDD elements of the file, and we want to look at completeness and internal quality again. So this is similar to the last design quiz. The only new thing we need to look at is the structure definition, which is specific to compound. Other than that, we want to check the type, comment, interpretation, examples, the template, and then the template rules used. So we have define struct flower, and it has three fields, X, Y, and size. So that looks well formed. We have a types comment. Flower is make flower integer, integer, natural. That's great. We have the interpretation, which says a flower with X position, Y position, and a side length. That's pretty good. We could be a little bit more specific by saying what the units are for the side length. So I could add in pixels here. Then we have two examples of flowers. And here's the template. We have fun for flower F, which is the correct name for a template. And then we have all three selectors. There's a bit of a problem here though. If you look closely, they've forgotten to add the parameter to each one of those. So that's not actually correct. We need to add an F in for all of those, but now that's good and complete. And for the template rules used, it says compound, 4 fields. That seems to be a typo. There's 3 fields, so we'll just change that. So we had one really big problem here in the template, and then these two little ones here, making the interp more specific, and this typo in the template rules used. These two are pretty small problems, so we would maybe give this a good or fair for the data definition, completeness, and internal quality. So the next criteria we need to look at is the HTDF elements of our program. So it says to choose either the toDraw OnKey or OnMouse handler and examine that. And we want to look for all the parts of HTDF. So that's the signature, purpose, stub, examples, tests, template, and the function body. We're going to look at the render function for this program. So if we take a look, we have a signature, flower to flower. That's actually incorrect. If we look back at our main function, it says that render goes from flower to image. So that's a good hint there that we have the wrong signature. So change this to image, and we'll keep going. It says renders the flower onto the screen. That's pretty good. We could be a bit more specific and say on the MTS at the correct X and Y coordinates. And then we could even add renders the flower of the given size. So that's a much more specific purpose. It really tells us how we're going to render our flower based on the compound data. So we can look at some check specs. We have one example here of size 20. That looks good. We have one of size 0. And then we have another one here of size 40. Seems pretty much the same as this one, so I'm not sure if it's really necessary, but those look good. Now we can look at the stub, which is well formed. There's a note about taking the template from flower, which is correct. And then we can examine our function here. This should really be on the next line. Not a big deal though. So let's look at the function body. First, it checks if the flower size is 0, in which case it produces empty image, which seems reasonable. Otherwise, we're scaling the flower by the size over 100 and then rotating by that size again. So that looks okay and seems to work, but by using this rotate function, we've actually created another case that we need to test. The rotate function can only actually accept numbers that are less than 360. So if we add a test here that, say, has size of 370, then in theory this should be 370 and that should be 370. And if we try and run that, we're actually going to get an error. It says expects an angle in degrees as first argument but given 370. So we really need to do something else to handle this case. So one thing that we could do is just add remainder here, which gives us the remainder when divided by a number. And we can divide by 360. So 370 degrees will really become 10 degrees up here. And if we run this now, all 9 tests passed. So that's a bit of a problem because we didn't really have enough tests to notice that we were missing that case. But the problem with the tests and the function body are kind of the same problem. So we'll take 1 mark off there and another for the incorrect signature, which will give us a fair for HTDF completeness and internal quality. So the final criteria we have to look at is, does the design satisfy the problem requirements? So it needs to be a world program, it needs to operate on compound data, and it needs to be within the scope of the course. So we were really clear that we want them to be simple. So this is definitely a world program. The world state is flower, which is clearly compound data. And there was nothing that was outside the scope of the course or overly complicated. So the last thing we'll do before we're finished is we'll copy this here and we'll actually run our animation. So there's a flower growing and spinning, and when we click we get a new one. So that's pretty cool and it seems to work well. So this design does indeed satisfy the problem requirements, and we will give it a good. So this was a very good solution to the flower program. It had a few inconsistencies here and there, but really overall it was very well done. So if this was your program, I'd be very proud of it. Okay, so now we're going to apply the rubric to our simple editor program. So again, we'll look at the first 2 criteria. Is the program safe and is it commit ready? So we see we have 2 requires here. Those are the ones we want. We'll quickly check for any that might be hiding within the file, and we're good there. So this gets an acceptable for safe. And for commit ready, we'll take a quick look through the file for any scratch work left behind or anything commented out that shouldn't be. And it looks pretty good. We've got signatures, purposes, and stubs commented out. all of our check expects and function bodies aren't commented out. That's what we want. So this will get a good for commit ready. So the next criteria we're going to look at is all of the HTTW elements, and we're going to check completeness and internal quality. We'll start with the constants. We have a width, a height, an empty scene defined using those, which is good. Text size, text color, and a cursor defined with the text size. So those look great. They're all well formed. And that seems like a complete set of constants for this program. Next, we have a data definition that is compound, and we'll check to make sure that that is the world state. And here in our main function, it is editor to editor. We have a purpose, simple editor, and it tells us what to start the world with, which is good. And here's our main function. We have two Big Bang options, toDraw and onKey. Both of their handlers are there. And if we look through the file, there's our render handler, and there is handle key. So everything is present. Our main function is well formed and correct, and our constants are complete. So we will give this an excellent for HTTW, completeness, and internal quality. Next, we'll look at the HTTD elements of the program. So here's our data definition. We have a structure definition here. Editor has pre and post, and those are both strings here in our type comment. And the interp says pre is the text before the cursor, post is the text after. That sounds clear. We have three examples here. We kind of have two cases. We have the case where the string before or after the cursor is blank, or when it's not. So really, I think we should have one more example to be the case where there's text both before and after the cursor. So we could just do this, and that would be more complete. We see here we have a template. It's correctly named, and it has both of the fields of the compound, and in our template rules used, we have compound 2 fields, which is correct. So we had that one little error with not quite enough examples, so we'll give this a good for completeness and internal quality of the data definitions. So next we'll look at the HTTF elements of the file. So since we looked at toDraw last time, let's look at the onKey handler. Here it is. So we have the signature, editor, key event to editor. That's correct. It says a key handler for a simple editor. That's good. We could be a little bit more specific, maybe list the functionality it has. So it looks like we have backspace, left, right, and inserting keys, but this is all right. And next we have a bunch of check expects. So we have some testing different letters. We have backspace, left, and right. We have a stub here, and then here is our function. This looks well formed, and if we run it, so all those tests passed, but actually I think we're missing an entire case here. So we can see that by making another check expect for the case where we press a key that doesn't have any specific functionality. So maybe the up arrow, and in that case we would want to just return exactly what we got. But if I run that, we get a failure, and it says conned, all question results were false. So that's because at the end of this conned, we're actually missing a case where we say else e. So if you press a key that's not one of these, we just want to return the same editor we started with. So now this all passes, and we do in fact have a complete set of tests now that we've added that one, and this looks pretty good. And now we don't have to look in detail at these helper functions that this person wrote, but we should check to make sure that they've followed the recipe in each of them. So if I scroll through, I've got signatures, tests, purposes for all of them. And because our key handler function works, we can tell that these are in fact doing what we need them to. So that looks good. So we had that one problem. Again, it's kind of the same problem in the body and in the tests. So we'll take off one mark for that, and we're actually also missing a note about where we got the template from. So that should say template from key event, and if they'd had that, they probably wouldn't have forgotten the else case because that's part of the template. So that brings us to a fair for HTTF internal quality and completeness. The final thing we need to look at is, does our program satisfy the problem requirements? And in fact, I believe it does. We have a world program that operates on compound data. It's definitely within the scope of the course, and we can try running it. Paste it in there. We get our little editor window right here, and I can say hello, and it all works great. So this is an excellent solution. We had a couple of problems, but overall it followed the recipes. It works well, and it definitely satisfied the requirements of the problem. So we'll give this a good for satisfies the problem requirements. And again, if this was your solution, I'd be very proud. So now you're ready to apply this rubric in the peer evaluation part of the final project. And you'll have to do 5 peer evaluations in order to complete the final project. Just as a final note, if you get someone's solution and it's missing any image constants, that means they may have accidentally tried to copy code in that had images pasted directly into the Racket file, and those will have disappeared in the peer evaluation. So don't penalize them too much for that. If you can tell what the image was supposed to be, just put in a placeholder image to run the program, and you can evaluate their work as if the image wasn't missing. It's been great looking at all of your final projects. I'm sure you'll have a great time seeing the work of your peers. And make sure you complete all of your peer evaluations by Thursday, July 9th at 23 o'clock UTC.